Have you ever wondered why in our periodic table in the electronegativity trend, it increases as it goes upwards and the trend increases as it goes eastwards? So this being said, on our periodic table based on the electronegativity trend, our fluorine element is the most electronegative among these elements with an electronegative value of 4.0. In reference, in terms of its atomic radius, the smallest atomic radius among all of these electronegative elements, so this excludes this noble gas since they are not electronegative themselves, the smallest radius would be fluorine. So how does these factors connects and explains the electronegativity value and behavior and characteristics of fluorine? And all of these concepts, all of these questions can be explained by the underlying concept, which is called the effective nuclear charge, which we'll be discussing on later down the line. So, as you can see, in a neutral atom, the number of atomic number is equivalent to the number of protons and to the number of electrons. So just for example, in our carbon atom, we have the atomic number of 6, so thus this carbon has 6 in a neutral atom. This has 6 protons and 6 electrons. So as you can see in our periodic table, the trend in this periodic table has an increasing atomic number. Thus, its number of protons to electrons is also increasing in a neutral atom. So hydrogen has 1 proton and 1 electron all the way to the last element of organism. This has 118 protons and 118 electrons. So how does this correlate to an effective nuclear charge? So let's have here specifically in a fluorine atom. Fluorine, being the most electronegative element, has the atomic number of 9. So this being said, our fluorine in a neutral atom has 9 protons and it has 9 electrons. And its electron arrangement, as you can see here, we have 2 electrons on the first shell on the 1s2 energy level, and we have 7 electrons on its second energy level, or the 2s2 2p5. So how does this affect the effective nuclear charge of fluorine? So as you can see, our proton are positively charged particles attracted to its opposite charged particles, which are the electrons. So between a proton and an electron, they have an attraction going on with each other. So let's take a closer look on what is an effective nuclear charge. So an effective nuclear charge, in simpler terms, tells us on how much of the nucleus attraction is felt by its outermost electrons. So the protons being a positively charged particles, it has a certain influence of attraction towards these valence electrons, which are negatively charged particles. So this effective nuclear charge has a number of couple of factors that affects it. So first is the distance. So we have this in universal concept known as the inverse square law, or in simpler terms, the greater the distance, the lesser the attraction becomes between particles or radiation. So this can also be found in Coulomb's law, which, as you can see, the attraction between the nucleus and the electron decreases or increases as it approaches or as it lessens the distance between the two of them. So similar with our universal gravitational force. As distance increases, the force of attraction decreases. So this is one of the factors that affects the effective nuclear charge. The second one is what we call the electron shielding. So basically, electron shielding is the reduction of the nucleus attractive force experienced by an electron due to the presence of other electrons. So let's have here again our fluorine atom. This is a fluorine atom. We have 9 protons and 9 electrons in a neutral atom. So this positively charged proton has an attraction force towards its opposite charge particle, which is the electron. It's negatively charged particle. So as you can see in the first energy level on the 1s2, we have 2 electrons, and that 2 electrons shields the outermost or the valence electrons from this influence of positive attraction from the nucleus. But in this example, we only have 2 electrons that shields the outer electrons out of the positive attraction from the protons itself. So with that being said, we can only say that there's lesser obstruction from the outermost electrons or the valence electrons being affected by the force of attraction or the force of attraction from the nucleus reaching them, the outermost electrons. In comparison, let's have here our magnesium. Our magnesium has an atomic number of 12, thus we have 12 protons and 12 electrons in a neutral atom. But in comparison, our outermost shell or our outermost electrons, the valence electrons, are located on the third energy level. So this is our 3s2. So as you can see, our magnesium, in comparison to fluorine, in order for the influence of these 12 protons to reach our valence electrons, it has to go through, let's count them one by one. We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 electrons. Thus, as per our definition, it's the reduction of the nucleus attractive force experienced by the valence electrons due to the presence of other electrons. So in comparison between our fluorine and our magnesium, our fluorine has greater effective nuclear charge than the magnesium, basically because the influence of its nucleus is preserved all throughout its outermost electrons or its valence electrons, in comparison to our magnesium, which only retains at least 2 of the positive 2 charge of the protons affecting its valence electrons on its outermost shell, located on the third energy level. So our fluorine is located in the second energy level, its valence electrons. So with that being said, on those different concepts we've discussed, electronegativity increases due to the effective force of attraction felt by the outermost valence electrons all the way from the nucleus. Because protons has a positive charge, it's attracted to electrons, so it increases as its effective force is felt towards its outermost shell of valence electrons. With that being said, to conclude, fluorine is the most electronegative element because first, it has the right distance to maintain a degree of effective nucleus attraction. So the attraction of the protons, its positive attraction to its outermost electrons or the valence electrons. And second, in comparison to other elements, it has the least number of inner electrons. So as you can see, we only have the core electrons, that is in the 1s2. That affects electron shielding of its valence electrons, which is located on the 2s2, 2p5. So basically, there's a greater force of attraction felt by the outermost electrons because there are only least amount of electrons in the innermost shell protecting or affecting the reduction of the nucleus influence towards its outermost shell. Okay? So in addition to that, fluorine also has the smallest atomic radius because of the intensity of its effective nuclear charge between the protons and the electrons, holding it together. So there's a greater force of attraction within the fluorine atom's nucleus atomic radius compared to other element. All right. So I hope you learned something from this discussion, and I'll see you in the next one. Thank you.